the gap for the cement. Now the foil of cement, the layer of a cement, is between 15 and 40 microns, right? That's the thickness of the cement. So you see, this is the cement, and it has it's round there. Half of that round, half of that circle, is the thickness of one molecule. So you can imagine two molecules, one over the other, of cement. It's actually more than two molecules, but just imagine like that, like two molecules, and you can't squeeze it more. So that's the thickness of the cement. Okay, that's the minimum thickness of the cement. You can try to press it. You need the force of the impact between two planets. It's impossible. Okay, the patient is not able to give this, no matter how much you tell the patient, bite down. Come on, that's crazy. Okay, our cement is a fluid, that's true. Okay, but this fluid has a minimum thickness, and it's blue is the coping, the metal coping or zirconia, whatever it is, the crown. Okay, and B has to go to A. Yeah, you see, black is the tooth and red is the cement. And why doesn't B go to A as it should? Because there's the cement there. Okay, on the other side is a symmetrical and identical phenomenon, right? Because this is just one side of the abutment. So this space, if you remove the red between the two, then the blue contacts the black. But the problem is, where do you have the space for the cement or you don't? Don't try to press it, because it cannot be pressed more than whatever it is, 20 microns, 40 microns. It depends on what cement you have. Now, just imagine that from A to B, I draw a line. See in the magnified image. So that's a triangle. From B to C, that's a perpendicular. From B to C, it's a triangle, right? It's a magnified image of what happens there at the margin of the tooth and the crown. So AB is the gap. AB is the gap between the crown and the abutment. So if you don't do a shoulder there, you won't have a gap. It's going to be just an adaptation between B and C. What, 20 microns? Nothing. It doesn't matter. So it's easier, isn't it? If you don't have this shoulder, you don't have this gap. That's true. But let me tell you something. It's still high. It's still high in occlusion. You still have a high spot in occlusion. So you don't solve the problem. You solve only half of the problem. But the main issue is there. Before cementation, it was okay. After cementation, the patient says, oh, I feel a little bit. And the dentist says, oh, you go home and you don't feel it. Yeah, right. Or you trim. You trim and you say, well, that's it. I don't know. Now it's okay. Yeah, it's okay. Go home. Yeah, that's not the right way to do it. You have to have the space, the right space for the cement. So the problem is there, no matter if you have the shoulder or don't have the shoulder. You need the space for the cement. So you don't have to have a lot of space for the cement, but the right space. So supposing is 40 microns, you need 50 microns. Yeah, 50, 60 microns, that's it. The cement needs a thin layer. The cement doesn't have to be thick, but it needs the minimum space, a little bit more than the minimum space of its own minimum thickness. So you have to know what type of cement you're using. So most of the times we do use shoulder preparations, not knife edge preparations. And then you have the two problems if you don't have the space for the cement. First, that the crown is high, and then you have the gap between A and B, in between the crown and the tooth. And there you will have a little bit of cement for the first part of the time, but then the cement goes away, is washed by the saliva, and there you'll have food retention, and eventually your abutment will be destroyed. Now, coming back to our triangle, you see, let's suppose we have a straight shoulder there, 90 degrees. This is not used anymore, but just suppose it. You see, alpha is the angle between the insertion axis and the inclination of the abutment. 3 degrees, 5 degrees. Now it's 3 degrees. Suppose it's 3 degrees, and in this situation, well, you just calculate. BC is the minimum thickness of the cement. Yeah, so sinus is BC on AB. This is regular, simple mathematics, right? It's nothing special, which is the cement divided to the gap, right? And now it's easy. Gap is G, cement is C. G is G sin alpha equals C, and the gap is the cement divided by the sinus of alpha. You don't have to calculate anything, because if the sinus, if the angle is very small, the sinus of this angle tends to be 0. So if sinus of alpha is 0, then it doesn't matter if the thickness of the cement, the gap will be infinite, right? That's it. Something divided on 0 is infinite. Okay, so it doesn't get in. You do, of course, because it's not 0. It's a little bit of an inclination, but, okay, if there's 3 degrees and only 10 microns excess of the minimum space comparing to what you have, okay, only 10 microns lacking, okay, you have 20 microns interspace and you have 30 microns minimum thickness of cement, then you have 10 microns less, and then you have 0.5 millimeter high coping or crown. That's crazy. That's crazy. I remember my students once calculated this, and they called me and they said, wow, really? We made a mistake. And I said, no, there's no mistake. That's the truth. Now you found out the truth. So when does it happen? When you suppose that you don't need space for the cement. Yeah, you don't have to have friction, direct friction between the crown and the abutment. It has to go smoothly, nicely, and sit only on the shoulder. Okay, you remember in all the movies the technician was doing this, was applying the foil of wax and foliating with wax, and then the spacer, in order to give enough space for the cement. Now this is very important, what kind of a cement you're using. You have to know it's 20 microns, 30 microns, 40 microns, maybe 17 microns. It's not that one is better than the other. It's just that you have to know and tell the technician, listen, I have a thick cement. There are very good thick cements and there are very good thin cements, but you need to know what cement you're having and tell it to the technician. So if you look on the lateral, you see sometimes you see that image with twisted on the left lateral. You see at places, you see the cement has enough space to go, because you say, oh, it has to be straight. It's not. If you look microscopically at the dimension of microns or tenth of microns, it will look like that. That is our coping, and on the right side is our abutment, right? And in some places you see the cement has enough space to go. In other places where you have the red arrow, there's no space for the cement, no space at all. What do you have there? Air, nothing. Just the highway for microbes. There you have the cement, but here is what? Here is air, just air. Okay? There's like two bumpers, one in front of the other, and there's no space for the cement. What do you have there? Highway for the microbes. What do? They eat your tooth, your abutment. That's what they do. And it is also protected. I mean, it's inside. You know, if this free space goes out, then microbes can go in and out. If not, they try to find food in a vital abutment if you left it vital. If not, they simply eat dentin because dentin is good anyhow. Microbes like it. Yeah, and then instead of the abutment, you will find, who knows, a carrot. It once happened to me. Yeah, the message is very simple. When you cemented it, that doesn't mean that the cement is uniformly distributed on the inside and you find cement everywhere. Yeah, but where the distance is smaller than the minimum cement thickness, then you have this problem. And maybe this free space prolongs, extends to the margin of the crown, and then just that's it. The microbes from the oral cavity will move freely in between your abutment and your crown, even if it is cemented. So the ideal space is 40 microns, 50 microns, 60 microns even. Okay, so the dentist must know that and tell it to the technician. And the technician should ask, tell me, what kind of a cement are you using? Okay, and yeah, it's true that at times technicians, they make the space bigger, like 70 microns, and then they say, okay, it doesn't matter how much we, I mean, the thickness of the cement doesn't matter because I left 70 microns and that's fine. And most of the technicians, when they work on CAD, computer-assisted design stage of producing crowns, they tell the milling machine, leave 70 microns gap for the cement, and that's it. The thinnest cement seems to be the glass ionomer, like 15 microns is the thinnest. The resin cements, they vary from 20 to 40 microns. And imagine that your impression was taken in a compressive way, yeah, and your abutment is already smaller. Your die in the lab is smaller than the abutment in the mouth because the impression was compressive. Then you have to give even more space, right? So all these things have to be taken into consideration. Before, when we were using spacers, we would apply several several layers of spacer, and you had to wait between the first layer and the second layer to dry, and it was a mess. I remember that it was like 1.5 hours just to start working, just to apply the first layer of wax on your die. Now with the milling machines and the CAD, it's easier. Yeah, because you just tell the CAD, the computer-assisted design program software, leave this space in between. And this is really to be found everywhere. I mean, it's so easy to work with digital technology today. Everybody has it in every single town. So yes, you go to 60 to 70 microns today. And technicians often know that for some dentists, they have to leave more space. For other dentists, they can leave less space. Yeah. So if we do shoulder preparation, we should have free access of the crowns until they touch down. Okay. And in between B and A, when B falls down on the shoulder, you need to have a space for the cement. Maybe smaller, just between A and B. Yeah, but otherwise it should touch freely on the shoulder. If you feel a small retention just at the end of your checking the crown, that may be okay. But if not, if it's friction all the way, that's completely wrong. So it has to go free until it does eventually a small tug back there at the end. Okay, you can check easily with there inside with impression material, and you see, is it very thin and almost washed away, or is thick? If it's thick, you have a problem. If you do knife edge preparation, you can't do that. It has to fit perfectly. Yeah. The shoulder preparation, you can have larger copings because the thickness of the shoulder would compensate for it. But if you have knife edge preparation, it has to fit perfectly around the tooth, and there you have to be much more precise than in a shoulder preparation with the gap for the cement.